For our final project, we decided to be able to measure the frequency response of different systems. So here we have a sample system, and we're going to run it just for a little bit just to show how it goes through the different frequencies. So slowly it'll reset itself there, and this is when all the set of communications are happening. And there you can see it starts iterating through different frequencies and is slowly speeding up. You can see it shaking as the frequency of its motion is increasing. And if we look here, we can see we're slowly going through all the frequencies and getting faster and faster. So there were actually 2 threads running on the Raspberry Pi, so that way we have the accelerometer data collecting nonstop. So really quick, I'll generate some plots, so that way we can see what the data looks like that got outputted. Slowly updating, takes a little while to run. Okay, so now that these data files got updated, we can take a look. This is what the raw data looks like that we collected from the accelerometer. And then this is the frequency response of the system. This is the what we wanted to get out of this project. As you can see, there's at 40 hertz, there's like a peak, so that tells us like at what frequencies like the system starts to like have issues. And we can see here, this is the recommended input shaper that you should use as ZV. So with this, you can now fix your system and like be able to run the motors at different speeds than you think you should in order to account for the peak and the resonance frequency at 40 hertz. So yeah.